Hello, in this video we're going to talk about how you can write your own functions in Python. Creating functions lets you abstract your thinking in order to better manage the kind of complexity of a programming task. So rather than needing to think through all the details at once, you can think about just a couple of the details, organize those into your own little function, and then when you need to perform those series of steps, you don't have to think about all the steps, you can just call the function and the function already has written down how to do those steps. It's a little bit like making sub-recipes in sort of a giant recipe book, right? You don't have to worry about all the steps, you can just sort of break it out into little pieces. It's a little bit like when, again, I tell you to open up Jupyter, I don't have to walk through all the steps to open up Jupyter, I can just say open Jupyter and those steps have been recorded and in theory processed elsewhere. Speaking of which, that reminds me, you're welcome to play along with me, like try out these examples as I go. Trying these examples, learning, practicing things out is really the best way to actually learn and see how it goes. Finally, I don't totally have my notes all totally put together for this video, but I really need to get it recorded because I'm running out of time, so we're going to do it live and we're going to see how well it goes. All right, so creating a new function has its own particular syntax, which actually looks fairly different from everything we've done so far. So in order to create a function, we're going to use a keyword def for define to indicate that we're now defining a new function. We're going to put a space and then the name of the function, what we want to call this thing, followed by a set of parentheses with the list of arguments we want that function to take in the middle of it. So as a pro tip, when you're naming functions, name them after verbs. Functions are bits of program code that do things. So I don't want to just have a function called hello. I want to have a function that's say hello, right? Because that function at the end that does things. So use those verbs when you're naming things, and that'll help a lot with being able to write code that makes sense and is readable and be able to trace and understand your own logic. If you can't think of a verb to use for your function, it's possible that what you're thinking of isn't actually a function, but is actually a variable, right? A noun, a thing for us to think about. Okay, so we've got our list of parentheses. We'll talk about those arguments, our argument lists that go inside our parentheses. We'll talk about those more in a couple minutes. And then that's followed by what's called a block. A block in Python, which is basically going to be a chunk of code, right? A bunch of work. That's going to start with a colon on the function line, followed by a bunch of stuff that's all going to be on the further line down, but indented one tab or 4 spaces. So if you just hit the tab key, that'll indent it and you'll be good to go. So again, as an example, I can define a function called say hello that's going to take in a name argument, and this runs 2 lines of code, one of which is creating a variable, and then one of which is printing out that variable. What this will let me do is that it lets me then run my block of code. I can say hello twice, but I can now be able to think about how I want to say hello without worrying about all the details. I can just say hello to everybody. I can walk down the street and say hello to every different person I want. So I can take this example of this code, and I will pop it into Jupyter and run it, and we can see that then this lets me say hello to lots of different people without having to write out the concatenation and the printing and all that work over and over again. When you define a function, you're also going to define a list of argument names. So these are variable names. They're name tags that you're writing down as part of defining that function, right? So when you create a function, you're also going to create a bunch of name tags that function can use sort of for its own internal purposes. Then what happens is that when you call the function, whatever values that the caller, the user, I'm going to say, puts inside the parentheses are then going to get assigned to those name tags that you had previously created. So what ends up kind of happening is that if I define the say hello function that has a name tag, when I call say hello and give it a value of Joel, that Joel effectively is going to get assigned to the name variable. I don't actually have to write that assignment. That happens implicitly. It's part of how the language works. But what's happening is that when I call say hello, the string Joel is going to get assigned to the name variable, and then that way when I then say make my greeting be hello plus name, well, name is just a name tag that's hanging on the string Joel, so Joel is what gets added to my hello variable. It's a little bit like if you go to a party, there's like a table with all the name tags on it, and people come in the door and grab a name tag. It's that kind of idea, except that it's going to be whichever arguments that we pass in are going to get assigned to get handed these name tags, and so that we can then refer to those name tags as they sort of whoever's coming in the door and able to use these kinds of functions. It's worth noting that it doesn't matter what you name the arguments. They're just variable names, so you can name them whatever you want. Please give them descriptive, informative names. It'll make your life make a lot more sense, right? If we called this name string, that would help a lot. But again, the name tag exists only actually within the function, so no code outside of it knows what that variable name is, so you can call it really whatever makes sense within the context of the function. It's worth noting that this assignment process actually becomes a lot more explicit when we're defining functions that take keyword arguments. So if I actually want to make a greet function that actually lets me specify not only the name but also the greeting, or specify a greeting, I can do that by saying there's my greeting variable, right? It's my name tag, but I can also put an assignment operator and then the default value that I want to be given that name tag. So the idea is that like when I create this function, I'm making this name tag, hanging it on a person by default. If somebody else then walks through the door and says, hey, I'm greeting, and we're like, oh crap, we better give you that name tag. We're going to pull off our default and give it to the new person. Like hi, when hi walks through the door, they're going to get assigned that greeting variable. So that's what they're going to be. So that when we actually run the function, greeting has a value of hi. But if nobody walks through the door and I need to run the function, right, there's no argument there, then I'll be able to use whatever the default value is that hello world is. So the important point here again is that the variables, the parameters are really just variable names. They're name tags, and we're assigning values to them by passing that input into the function to be used again later. So here's a really important piece to note. The variables you create inside of a function, which includes the parameter, the argument name tags. So arguments and any other variables you make in the function are what are called local variables. They exist only inside that function. So again, these are like name tags that only exist inside that room. Outside of that room, they don't apply. They're pet names for within that room. So as an example, right, if I have a function that I've defined called make full name, it takes in two arguments, a first name and a last name. And if I take those variables, concatenate them, and assign them to a variable full, this variable full, along with this name tag and this name tag, only exists inside that function. Outside of the function, when I'm not indented anymore, they don't apply, they don't exist anymore. So if I run my make full name, Joel and Ross will get add together and that gets assigned to my full value. But if I then try to print out this full variable outside of that function, you'll notice that I end up getting an error because Python says that the full name tag doesn't exist because it only exists inside of that actual function. If I tried to print out full from inside the function, it would work just fine. But now it's that the function is doing that printing work. Therefore, I'm able to access that kind of information. Outside of the function, it doesn't exist anymore. Similarly, there's also no inherent relationship between variables that are declared inside a function and variables declared outside a function, right? The fact that they share the same name actually has no real meaning. It's just pure coincidence. So, for example, if I declare a variable first name outside of this function, this is what's called a global variable. It's available everywhere, right, globally. If I also have a variable first name, right, the same name tag, but this one is local, it only exists inside that function. So it's like there's sort of the outside world first name, but then there's the inside the function first name. What then happens is that when I call say hello Bob, right, remember the Bob value is going to get assigned to the first name tag, but that's only the first name tag, the one that lives inside the function. The one that lives outside the function, right, the one that's global, it's not sort of a secret function, the secret that only exists inside this function, will continue to be Alice. It'll continue to be sort of the same variable that was defined the first time. So that when I print out the global level, right, the one that exists outside the function, that's going to continue to be Alice, even though I assigned Bob to something called first name earlier and later, right? What did I do? Oh, sorry. Try to change examples too fast. There we go. So we can try this out to make this work. Similarly, it means that just because I assigned a value to assigned the value Alice here is not necessarily going to impact any of the arguments that I specify here, right? Even if I try to leave off this argument, I can't say that first name does have a value, Alice. It's because it's still expected argument. I still need to figure out who's going to get that individual secret local name tag separate from the global values. In particular, you don't want to use any kinds of global variables, as you want things to exist sort of, anything that is going to be sort of used in a function should be defined in that function or be an argument to that function. The reason this is so that way if you modify or change the function or you change something outside the function, it's not going to ruin how your function works. The only things you want to exist outside the function are things that are going to be constant. The things are not going to change ever. Things like pi or the gravitational constant of the universe. They're not going to change, so we can sort of leave them alone. The thing we might do with naming is we maybe are going to make a last name argument that might be Ross, because I'm going to say my last name is not going to change for the purpose of this program, so we're just going to leave it the way it is. That way, everybody can always assume the last name is Ross, but I don't want to keep typing the word Ross over and over again, so I'm just going to assign it to a variable to be able to use that later. Notice I made it in all caps. It's generally a good idea to make constants in all caps as a way of indicating that's a value that's not changing. You shouldn't ever assign other values to it. You should sort of just leave it as it is to how it goes. The last thing to note about basics for defining functions is that functions can we can specify how a function returns a value as a result. Functions can only return one single value, but we can specify what that value wants to be. Remember how we said that, like, the round function returns the rounded number and the len function returns the length of a string? We can specify what we want a value to return. Returning a value is different from printing, and I'm going to get into that in just a second. All right, so let's look at an example. So I can I have a make full name function. It says first name and last name. It's going to assign those values to some full name variable. I can then use the return keyword without parentheses. I'm just writing the word return space, then the value I want to return. And that's going to specify that when the function finishes, when it exits, that's the value that's going to get returned and assigned, and can be assigned to some other variable. So that when I call make full name, that's the value that will get assigned to the my full name variable. So to demonstrate this exact same thing in Jupyter, right, I'm going to have my make full name function. It returns the full name. I'm going to call that value, assign it to the my full name variable, and then I can print out that variable, which you'll then be able to see it prints out Joel Ross just as I expected. Now, the important thing to note, and this is the trickiest part about dealing with return values, is that return values are different than printed values. So if I don't actually assign this to a variable, right, I'm just going to call make full name, you'll notice that Jupyter still outputs the content. It still outputs Joel Ross. However, I can't do anything with that Joel Ross. I can't, for example, count the length of it. I can't figure out how many letters are in my name because that value hasn't been assigned to any kind of variable. So when I return a value that's producing a result that we're going to need to assign to a variable, my full name, so that I can actually do some work with it, right? I can get the length of my full name. Only one, my full name. So again, that's different than printing. If I print a function or have a result, so if I say make full name is instead going to print the full name, then what will happen is when I execute the function, you'll notice that the content, Joel Ross, got printed. That's because when I said make full name, it took those two values. Joel got assigned to first name, Ross got assigned to last name. It added them, concatenated them together to make full name, and then it printed it out. Done. It then took the result of this make full name function and assigned that result to my full name. The result meaning what was returned by this function. This function doesn't have a return statement, which means it didn't actually return anything. So that if I ask to print out what my full name is, now it prints out a value called none. And none is a Python value, right? It's kind of like it's a value like 0 or hello, but it's a value that means that there is no value. It's sort of it's kind of like the 0 of all of variables, except it's not actually 0 because 0 is a number. But what that then means is if I try to, for example, take the length of my full name, I'm going to get an error because none, objects of none type, right, the none kind of thing, doesn't have a length because it's none, it doesn't exist. So in this case, where I try to say make a full name and get the length of that, the whole thing broke because I wasn't actually returning the value to use later. I was just printing the value that for me to see. Again, Jupyter makes this really complicated because the distinction between calling a function and printing from a function becomes very vague in your actual cell where you're doing this work. You'll notice that when I print it out, it prints out the string. That looks great. If I just return the value and sort of just output it as the result of that expression, you'll notice that see how it puts the quotes around it? Right? Because it says that therefore the result wasn't actually the text that got printed, but the result was a string value for me to be able to use. This distinction between returning and printing is even more noticeable when we're working with when we're doing Python on the command line and we're using Python scripts, which is what we'll talk about in a later module. But I want to give you a quick demo because it helps explain what's going on. So for example, if I define my function, say hello, that takes in a name and returns that, I can execute this line of code in Jupyter. Do I have Jupyter or Jupyter? I just minimized Jupyter. In Jupyter, right, it will output the content hello world, but if I run this through the terminal, then you'll notice it doesn't output anything because I didn't say to print anything. So while Jupyter might show us the output, the terminal, the command line, won't actually do any of that kind of work. If I then modify my code so that it actually, instead of returning hello, it instead prints hello, Then when I re-execute the script, you'll notice now it actually outputs it. So anything that's printed is stuff that's going to be outputted for us to be able to see. If you don't print it, it's not going to be outputted for you to see, even though Jupyter will sort of show you what it is anyway. But you have to pretend that Jupyter's not doing that by always making sure you're assigning values to variables, and then you don't have that problem. But so again, to be able to keep these things different. So again, distinction is if we're printing, when we're printing a value, a printed value is for a human to be able to see. Like that's sort of the result. It's like the poster you want to hang on the wall for other people to be able to read. A return value is an internal value. It's supposed to be used by the computer to be able to use later inside of your programming cycle. So if you want to calculate a value and then use that value to do more work, you're going to want to make sure you're returning that value. If you want to calculate a value and then just share that value, show it to somebody else, you're going to be printing that value. So this distinction is very difficult for a lot of students to understand, which is why I'm trying to harp on it a lot. We'll do more practice with this kind of thing. You'll be able to see more examples of how this works and do more work with this practicing as we sort of go to be able to make these things come together. It's worth noting, it's possible to have It's possible to have my function do both things. I can both return the full name and print the full name, in which case it returns the value, right? So then I can say my full name is the thing that I wanted. I can get the length of my full name. Everything works great. And it also prints out the name for me to see. This is considered bad. This is a bad idea. This is bad practice. Part of the reason is that when we're developing functions, we really want them to sort of just do one thing, right? We want them to just be kind of without side effect. We want to be able to say make a full name without also having that have to cause a bunch of extra printed output for me to see later. So for example, if I was really just interested in knowing the length of my full name, I didn't want to see it, but now I have to deal with it anyway, right? I'm really just interested in that 9, but I'm also getting this extra stuff printed out, which could get in the way of the other kinds of user interface, the other kinds of output, or the other kinds of content I may be interested in seeing. So in general, your functions are going to do one of two things. They're either going to return a value for you to use later, or they're going to print a value for you to see, and that's going to be sort of your final result. I generally recommend naming any function that's going to print a value, call the function print. So that might be called print. I might call this one print full name because it prints a value. If it's going to return a value, then you can name it something else like make full name, get full name, calculate tax, whatever you need to do. But if it's not actually a printing function, you instead are going to want to make sure it's returning something and then print that resulting value, right? Take that, call the function, save its results as a variable, and then that's the thing you can be able to print once you're done. So what we would really like to be able to do is we would like our function to be our make full name function. We would like to be able to return that full name. We'll then call the function, save it in a variable, and then if we decide that that's what we want to do with that variable is print it instead of getting its length, I can do so, and everything will work just fine. So that's the basic idea behind writing functions. The pretty much idea is we're going to define a function, we're going to give it a name and an argument list. We're then going to call that function by putting the parentheses and passing in a value to the argument list. We'll make sure our function returns a value so that when we call the function, we can take that returned value and save it in another variable. And then the way we'll end up doing that is we'll write a bunch of different functions. We'll have one function take in some input, return a result, and then have that result become the input, the argument to the next function, which can return another result, which can then be used for another function. So we can basically start chaining these things together in order to produce fairly complicated programming interactions. We're going to talk about how to do that in more detail in a later module, I think the next module, but this should be able to get you started at least being able to write and call some basic functions so you can begin doing some simple programming in Python.